Welcome back to Rajur Academy. In the previous session, we already discussed Module 1, Module 2 and Module 3 numerical problems. In this session, we are going to discuss the remaining problems of Module 4 and Module 5. In the Module 4, there are two questions. First one is 7C and second one is 8B. In Module 5, there are also two questions, question number 9C and question number 10B. Before going to discuss all these questions, I would like to thank you all because of our channel reaches 1,50,000 views. That's only because of your love towards our channel. Thank you all and keep supporting us throughout our journey. I am Shivaprasad. Let's solve these questions.
Rajur Academy. Grow with knowledge.
The first question is for 6 marks. Discharge of 18 cubic meter per second. The rectangular channel of 6 meter wide and the depth is 1.6 meter. Okay, let's write the given data first. Discharge Q is equal to 18 cubic meter per second. Width equal to 6 meter and depth 1.6 meter. The first question is to find the specific energy. Second is critical depth and state whether the flow is subcritical or supercritical. To solve this question, you have to know the formula for specific energy and critical depth. The first one, specific energy E is given by depth y plus velocity v square divided by 2z. Second one, critical depth is given by yc is equal to discharge per unit weight, that square divided by g whole raised to 1 by 3. Let's solve for specific energy. We know that Q is equal to V into A. Discharge Q is equal to 18 and we don't know the velocity, keep it as it is, and area is given by breadth into depth. I am considering here depth is equal to y. So 18 is equal to V as it is, width is 6 meter and depth is 1.6 meter. Therefore, we will get velocity V is equal to 18 divided by 6 into 1.6. After solving, the velocity equals to 1.875 meter per second. Now, substitute this velocity in specific energy equation. E is equal to y, depth is 1.6 meter plus the velocity is 1.875 divided by 2 into z is 9.81, that is acceleration due to gravity. After solving this equation, we will get a specific energy E equals to 1.78 meter. This is the answer for specific energy. The second sub question is critical depth. Yc is equal to Q square divided by G whole raised to 1 by 3. We know that a discharge per unit width is equal to total discharge divided by width. Q is equal to total discharge is 18 divided by B is 6. We will get 3. Now, Yc is equal to 3 square divided by G is 9.81. That's whole raised to 1 divided by 3. After simplification, we will get critical depth equals to 0.972 meter. For sub question 3, we have to compare critical depth and original depth. If the original depth is greater than critical depth, then the flow is subcritical. original depth is greater than critical depth, then it's a subcritical flow. If y is equal to yc, then it's a critical flow. If the y is less than yc, then it's a supercritical flow. In our case, y equals to 1.6 meter, yc equals to 0.972 meter. Therefore, y is greater than yc. The flow is subcritical flow. If you solve this much, you will get a 6 marks out of 6 marks. Let's move to the second question. Just once read this question. The given data are the initial velocity of 6 meter, v1 is equal to 6 meter, and depth of flow y1 is equal to 0.4 meter, and the width b is equal to 8 meter. In this question, they are asking to determine whether a hydraulic jump will occur or not. Then, if occurs, find its height and loss of energy per kg of water. Determine the power loss in hydraulic jump. The similar question we already solved in the solution of model question papers. ಇನ್ನು ಯಾರಾದರೂ ಆ ಸೆಷನ್ ವಾಚ್ ಮಾಡಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಹೋಗ್ಬಿಟ್ಟು ಆ ಸೆಷನ್ ವಾಚ್ ಮಾಡಿ. Now, by using Frod's number, we can solve this problem. The Frod's number FR1 is given by V1 divided by square root of GY1. We know that V1 is equal to 6 meter per second. This is 6 meter per second divided by square root of G is 9.81 into depth is 0.4 meter. After solving, we will get a FR1 is equal to 3.03. Since FR1 is greater than 1, the flow is supercritical. Therefore, the hydraulic jump occurs. Hydraulic jump occurs. Since the hydraulic jump is occurs, then we have to calculate the height of the hydraulic jump. Height of hydraulic jump is given by y2 is equal to y1 by 2 multiplied by square root of 1 plus 8 fr1 square minus 1. y2 is equal to y1 is 0.4 divided by 2 square root of 1 plus 8 into 3.03 minus 1. After solving this expression, we will get y2 is equal to 1.52 meter. This shows the hydraulic jump occurs at a 1.5 meter of depth. Next, we have to determine loss of energy, that is given by HL is equal to y2 minus y1 whole cube divided by 4 times y1 into y2. HL is equal to y2 is 1.52 minus y1 is 0.4 whole cube divided by 4 into 0.4 and 1.52 for y2. Actually, the HL is a head loss, but the energy loss per unit weight is given by head loss. Therefore, HL is equal to 0.58 meters. The energy loss per kilogram of water, we have to multiply acceleration due to gravity to this answer. Therefore, the energy loss equals to 9.81 into 0.58. We will get energy loss equal to 5.69 joule per kg. Finally, we have to calculate power loss. The equation power loss PL is given by rho Z Q into HL. We know that rho, Z and HL, but we have to calculate G first. Therefore, G is equal to velocity V1 into area, which is given by Y1 into B. Q is equal to V1 is 6 multiplied by Y1 is 0.4 into breadth is 8. That's equal to 19.2 cubic meter per second. PL is equal to rho is 1000 into Z is 9.81 into Q is 19.2 into HL is 0.58. Therefore, power loss equals to 109,200 watts. If you solve all these conditions, you will get a full marks. Okay. ಏನಾದರೂ ಡೌಟ್ ಇದ್ರೆ ಕಮೆಂಟ್ ಬಾಕ್ಸಲ್ಲಿ ಕಮೆಂಟ್ ಮಾಡಿ, ನಾನು ಇಮಿಡಿಯೇಟ್ ಆಗಿ ಸಾಲ್ವ್ ಮಾಡ್ತೀನಿ. ಇಲ್ಲ ನಿಮ್ಗೆ ಇನ್ನೂ ಏನಾದರೂ ಕ್ವಶನ್ಸ್ ಇದ್ರೆ ಅದನ್ನು ಕೂಡ ಕಮೆಂಟ್ ಸೆಕ್ಷನಲ್ಲಿ ಪೋಸ್ಟ್ ಮಾಡಿ, ನಾನು ಆ ಕ್ವಶನ್ಸ್ ಮೇಲೆ ಕೂಡ ಸೆಷನ್ ಮಾಡಿಬಿಟ್ಟು ಸಾಲ್ವ್ ಮಾಡ್ತೀನಿ. ಯಾರೆಲ್ಲ ಇನ್ನೂ ನಮ್ಮ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗಿಲ್ಲ, ನಮ್ಮ ಚಾನಲ್ನ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗಿ, ಲೈಕ್ ಮಾಡಿ, ನಿಮ್ಮ ಫ್ರೆಂಡ್ಶಿಪ್ ಕೂಡ ಶೇರ್ ಮಾಡಿ. ಲೆಟ್ಸ್ ಮೂವ್ ಟು ದ ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್. Model 5. Design of Pelton wheel turbine required to develop shaft power of 95.6475 kilowatt. It's a very easy question. ನೋಡಕ್ಕೆ ಅಷ್ಟು ಲೆಂದಿ ಆಗಿದೆ, but it carry a 10 marks. The given data, shaft power P is given by 95.6475 kilowatt, working under a end of 60 meter, H is equal to 60 meter, rotational speed N is equal to 200 RPM, the overall efficiency nu is equal to 85%, the velocity coefficient CV is equal to 0.98. Also, they given a condition velocity of the bucket equals to 0.45 times the velocity of the jet. Therefore, VB, the velocity of bucket, that is equal to 0.45 multiplied by velocity of Z. Okay. To solve this question, you have to know the equation for velocity in terms of diameter and speed. So first one, the velocity V is given by CV square root of 2ZH. Then second one, V is equal to pi dN divided by 60. First one, velocity of the Z, Vz is equal to CV square root of 2 into Z into H. Substitute all the values, we will get Vz, velocity of Z, that is equal to CV is 0.98 square root of 2 into Z is 9.81 into head is equal to 60. After solving this equation, the velocity of jet is equal to 33.62 meter per second. From given condition, VB is equal to 0.45 Vz, we can calculate the value of VB. VB is equal to 0.45 into Vz, that is 33.62. We will get VB is equal to 15.13 meter per second. We use the formula VB is equal to pi dN divided by 60 to determine the diameter of the wheel. After rearranging, the equation will become D is equal to VB into 60 divided by pi into N. D is equal to VB is 15.13 into 60 divided by pi is 22 by 7 into n is 200 rpm. By solving these values, we will get diameter D is equal to 1.44 meter. That's it. If you solve this much, you will get a full marks. Next question. A centrifugal pump is to discharge 0.118 cubic meter per second. They are given Q is equal to 0.118 cubic meter per second. Speed of 1450 rpm. And they also given head of 25 meter. The diameter is 250 mm. D2 is equal to 250 mm. Then the width is 50 mm. Width B2 is equal to 50 mm. The efficiency of manometer nu m is equal to 75%. Here you have to remember some formulas. Those all are very important to solve this type of problem. So first one is tangential velocity u2 is equal to pi d2 n divided by 60. Second one, radial velocity vf2 is equal to q divided by pi d2 b2. Then theoretical head th is equal to head divided by efficiency. The similar theoretical head is given by u2 v2 divided by g. Finally, you have to remember the vane angle at outer periphery is given by tan beta 2 is equal to vf2 divided by u2 minus v2. Note down all these formulas. Those will help to solve this problem. Now we have to convert the speed from rpm to the radian per second. Therefore, n equals to 1450 rpm they are given. That will multiplied by 2 pi divided by 60 to convert in terms of radian per second. After solving, we will get speed n equals to 151.84 radian per second. The tangential velocity is given by u2 is equal to pi d2 n divided by 60. Pi into d2 is 0.25 given in the question, and speed is in terms of rpm 1450 divided by 60. u2 is equal to 18.95 meter per second. Second one, radial velocity vf2 equals to q divided by pi d2 p2. Q is equal to 0.118 divided by pi is multiplied by 0.25 into b2 is 0.05. vf2 equals to 3 meter per second. The theoretical head h is equal to head divided by efficiency of manometer. H is equal to 25 divided by efficiency of manometer is 75 divided by 100, that means 75%. We will get theoretical head equals to 33.33 meter. The theoretical head H theoretical equals to U2 V2 divided by G. 33.33, that is equal to U2 is 18.95 into V2 is as it is divided by 9.81. We will get V2 equals to 17.27 meter per second. The final step, the vane angle tan beta is given by Vf2 divided by U2 minus V2. Tan beta equals to Vf2 is 3 divided by U2 is 18.95 minus V2 is 17.27. After solving, we will get tan beta is equal to 1.786. The angle beta equals to tan inverse of 1.786, that is equal to 60.76 degrees. That's it. If you solve this much, you will get a full marks. If you have any doubts from module 4 to complete module 5, you can comment it in a comment section. I will try to solve your doubts. ಇನ್ನು ಯಾರು ನಮ್ಮ ಚಾನಲ್ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿಲ್ಲ, ಚಾನಲ್ನ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ. ಯಾರು ಸೆಷನ್ನ ಲೈಕ್ ಮಾಡಿಲ್ಲ, ಸೆಷನ್ನ ಲೈಕ್ ಮಾಡಿ. ಇಲ್ಲಿಗೆ ಡಿಸೆಂಬರ್ ಜಾನ್ ಪ್ರಿವಿಯಸ್ ಸೆಮಿಸ್ಟರ್ ಕ್ವಶನ್ ಪೇಪರ್ ಕಂಪ್ಲೀಟ್ ಆಗುತ್ತೆ. ಇನ್ ದ ವೆರಿ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಐ ವಿಲ್ ಡಿಸ್ಕಸ್ ಜೂನ್ ಜುಲೈ 2024 ಪ್ರಿವಿಯಸ್ ಸೆಮಿಸ್ಟರ್ ಕ್ವಶನ್ ಪೇಪರ್. ಆಲ್ದೋ ನಿಮ್ಮ ಹತ್ರ ಯಾವ್ದಾದ್ರು ಎಕ್ಸ್ಟ್ರಾ ಕ್ವಶನ್ ಪೇಪರ್ಸ್ ಇದ್ರೆ ಅದನ್ನು ಕೂಡ ನನಗೆ ಶೇರ್ ಮಾಡಿ. ನಾನು ಅದರಲ್ಲಿರೋ ಪ್ರಾಬ್ಲಮ್ಸ್ ಕೂಡ ಸಾಲ್ವ್ ಮಾಡಿಬಿಟ್ಟು ನಿಮ್ಮ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಒಳ್ಳೆ ಮಾರ್ಕ್ಸ್ ತೆಗೆಯೋಕ್ಕೆ ಹೆಲ್ಪ್ ಮಾಡ್ತೀನಿ. ಇಲ್ಲಿವರೆಗೂ ನನ್ನ ಕ್ಲಾಸ್ ಕೇಳಿರೋ ಎಲ್ಲ ಸ್ಟೂಡೆಂಟ್ಸ್ಗೂ ಥ್ಯಾಂಕ್ ಯು ಅಂಡ್ ಬೆಸ್ಟ್ ಆಫ್ ಲಕ್ ಫಾರ್ ಯುವರ್ ಎಕ್ಸಾಮಿನೇಷನ್.